Okay, so last time we looked at integration, basic integration for simple forms such as the integration of, let's say, 3x squared. All right, dx, it is very important to put your dx. This dx basically says we are integrating for x. All right, so for this variable x, this is what this dx means. This will be, remember that integration is just the opposite of differentiation. So first thing we can do is take the 3 outside, because 3 is a constant value. It does not affect our integration. And we will be integrating just the x squared itself. All right, so anytime you have a constant, you can keep it out of the integration to integrate. And this will be 3 times. So the integration of x squared is going to be, remember again, this is opposite. So this is going to be 2 plus 1 over 2 plus 1 at the bottom, opposite of differentiation. All right. So this will give us, and then obviously you're going to have to add your plus c, which is a constant in the case of indefinite integration. This plus c is very important because this basically shows that there is a constant value that is there, but we do not know the value of in the case of indefinite integration. If we simplify this, this will give us 3x cubed over 3, and then plus c, and then you're going to notice that the 3 and the 3 will cancel, and we will have x cubed plus c. All right, so this is the integration of a basic variable or a basic equation that we looked over. This is known as the general form. But what if we have sine or cosine or trigonometry? So this was general form, all right? What about trigonometry? So we're only going to be looking at sine of x. This will be, so the integration of sine x dx is going to be minus cosine x, all right, plus c. And the integration of cosine of x dx is plus sine x plus c. All right. Remember, an integration, it is the opposite of differentiation. So when we used to differentiate sine, we would get cosine as positive, and then the cosine would be negative sine, but we are doing the integration, so the signs are going to be opposite. All right. But these are simple equations. What if we, let's say we have something like 3 sine of 3x, okay, dx. What if we want to integrate here? So if you remember in differentiation, if we had something like this, if we wanted to differentiate this, we would take the 3 outside and multiply it over here, right? This is what we used to do for differentiation. For integration, we are going to be doing the opposite. So first, let's take out the 3 outside, the constant 3, all right? So this 3 is just simply this 3, we just took it outside. It's a constant, it does not have any effect. In this case, now we used to multiply for differentiation. In integration, we're going to actually divide. So what will happen here? We're going to have the 3, which is outside. Sine x will turn into cosine with a minus sign, because integration of sine x is minus cosine x, all right? So minus cosine of 3x, whatever is inside does not change over here. But now we will have to divide by 3. Because of this 3 value, we're going to have to divide the entire equation by 3. All right? And then we're going to have our plus c outside. So in other words, this is going to be equal to 3 times minus cosine. So let's keep the minus outside here. So minus cosine 3x all over 3. As you notice, the 3 and 3 will cancel again. In this case, at least, plus c, and this will be minus cosine of 3x plus c. All right. So the idea here, the main point here is if you have any variable inside or any constant multiplied by the variable inside, بتقسمونه, and you will divide it in the case of integration outside. Let us say we have something like this, cosine of 4x plus 3. All right. dx. The integration of this is going to be sine of 4x plus 3. Whatever is inside the brackets will not change, all right? But again, you will only divide by the value here, the one that is multiplied by x, okay? So it will be divided by 4 plus c, all right? So this is the only value that you will be dividing by, the 4 in this case. The 3, it has no effect at all on this because it's a constant value. The thing multiplied with your variable here is going to be the division of it. Do not worry if you have x squared, x cubed. I did not see any questions like that. This is the most complicated as it gets for trigonometry. All right. Last thing, or the next thing I should say, the integration of exponential values. If you remember, it was very easy. If you have e to the power of x, the integration of e to the power of x dx is simply just e to the power of x plus c. All right, integration of it is the same number you get. But in the case of, let's say we have e to the power of 5x dx, again, you will do the exact same steps. So the 5x will not change, e to the power of 5x. You're going to have your plus c over here. But because we have 5 over here, we're going to have to divide by 5. And differentiation, we used to multiply. Now we are going to divide. All right, so it's going to be e 5x over 5. Okay, very simple, very straightforward. And then the last thing that we looked over was the integration logarithmic, which was the integration of 1 over x. Okay, remember when you have 1 over x dx, you're not going to apply the general rule. This is not equal to x power minus 1 integration d of x, and then you're going to do x minus 1 plus 1 over minus 1 plus 1. Okay, you are not going to be doing this. This is wrong because at the bottom you're going to have 0. All right, so this is completely wrong. This is wrong. It is very simple. This is, if you remember, what was the differentiation of ln of x? If we wanted to differentiate now, right, d by dx, we used to get 1 over x. So if we want to differentiate, we get this. So if we want to integrate 1 over x, integration, we are going to get ln of x plus c. Okay, this is what it basically is. So instead of this is actually the absolute value of x, but it's not that important. So instead of applying the general rule, when you have 1 over x in integration, it simply becomes ln of x when you are integrating. All right. So let us look at a question. Let's say we have something like, just a quick practice, 2 plus 3x squared over x dx. All right. Remember that in integration, you can integrate each part by its own. So first thing we can do is we can do 2 over x plus 3x squared over x, all of this into dx. All right. In other words, we can also write this as the integration of 2 over x dx plus the integration of 3x squared over x dx. All right. We can separate each, if you have a plus or minus and you have components or elements بروحهم يمين ويسار هني, you can integrate each one by itself. So this is how you would solve this. So for the first one, 2, remember, is a constant. All right, this 2 is a constant, so we can just keep it outside of the integration, 1 over x dx plus, and now if we look at this integration, x squared over x, it simplifies and it becomes 3x. All right, remember, this is power 2, this is power 1, this becomes 2 minus 1, so it becomes x to the power of 1, which is simply equal to x. Okay, times 3. Again, 3 is a constant, so we can simply just keep the 3 outside and keep the x inside. Okay, so keep that in mind. The constants, you can always take them out of the integration to make life a bit more easier for you. All right. ف 2 1 over x dx plus 3 x dx again. Now you can do your integration. So this is going to be 2. 1 over x, as we have seen earlier, is just ln of the absolute value of x plus 3 into the integration of x is going to become x squared over 2. And of course, do not forget your plus c. All right. So this is going to be equal to 2 ln absolute value of x plus 3 over 2 x squared plus c. All right. Let's look at another example. Let's look at a longer one, a longer integration. So sine 5x plus cosine 2x plus e to the power of 2x minus 2 over 3x. All right. So if you see here, this tackles almost all the concepts that we have learned in integration. So again, remember, you can separate each one and do the integration by itself. So we can do the integration of x power 4 dx minus integration of sine 5x dx, right? Plus the integration of cosine 2x dx plus the integration of e 2x dx minus the integration of 2 over 3 x dx. Okay, so the first step would always be taking out the constants if you have any. In the first one, we do not have any constants, right? So I'm going to actually keep it in the same form. I'm not going to integrate yet because I want to integrate all in the same one step. Second one, again, you don't have any constants. Keep it the same way it is. Third one, we don't have any constants. We're going to keep it the same way. Constant يعني رقم بدون variable. يعني مثلا هني 2 over 3. This one, again, no constants. I'm just going to keep it here. And then you have minus 2 over 3. Then this 2 over 3 over here. This is your constant. This is a constant value. And then integration of 1 over x dx. And now we can integrate for each one. So the first one then is x power 4, general form, which is x power 5. You add 1, and then you divide by 4 plus 1, which is 5, minus sine of 5x dx. This will become, sine becomes cosine, and it will become a negative cosine. So this will become minus cosine of 5x. This is the first part, okay? It will become a minus cosine of 5x. And we have to divide by the constant multiplied inside, which is 5 inside over here, like this. All right. Make sure you do not confuse the signs. If you notice here, the minus, I took it outside as well. All right. So that there is no confusion with the signs, because you're going to have the minus here from the original equation, and then the minus here because of the integration of sine. Okay. Same thing again. This is going to become plus cosine 2x becomes sine 2x. Divided by the constant inside, which is 2, right? So again, this 5 just came from here, and this 2 just came from here, okay? That's it. And the integration of e to the power of 2x, integration of e to the power of 2x becomes e to the power of 2x, it does not change, over, again, the value of 2 over here. So it's going to be over 2. Again, this 2 is where we got the division of 2 from, what is multiplied by the variable inside, minus 3 over, or 2 over 3. The integration of 1 over x is ln of absolute x. And then don't forget your plus c. All right. Then you can simplify all of these equations. So it's going to be x squared, x5 over 5 minus and minus becomes plus cosine 5 of x, cosine 5x over 5 plus sine 2x over 2 plus e to the power of 2x over 2 minus 2 over 3 ln of absolute x plus c. All right. In this case, This was a very simple case. If you know, I mean, it looked very complicated, but it is very simple. All you just had to do was plug all your numbers back in. So what if we wanted to find the value for C? All right. Let's say we want, يعني for this example, we wanted to take the value for C. The question, it will mention something like they will say that Y, this is Y, all right? They're going to say that Y is equal to this, or Y is equal to the integration of this, okay? So here we will know that this is Y, all right? For example, they're going to give you a value for XY. They're going to say that, for example, the line or point has points such as 2, for example, and 3, for example, all right? Or they will say x is equal to 2 and y is equal to 3, all right? This is the same meaning. Or they might mention it as y of 2 is equal to 3. And I'm going to go through each one of these, okay? So this basically means this is x and this is y, okay? Coordinate system. This, again, this is very clear. This is your x value and this is your y value. And the last one is, this is your y value, all right? So this is your y, and whatever's inside the parentheses here, this is your x value, okay? So this is just 3 different ways of writing the same meaning. What you will do is, obviously this is a very complicated example here. So let's say we had an integration and we found the answer to be 5x cubed plus c, for example, all right? This was the answer of our integration. You're going to plug in the x over here, you're going to plug in the value for 2, and for the y, you're going to plug in the value of 3. And you're going to solve for your c value. So this will become like 3 is equal to 5 x cubed, which is 2 cubed, plus c. 3 is equal to 5, 2 cubed is 8, so 5 times 8 plus c. 3 is equal to 40 plus c. So our c is equal to 3 minus 40, which is equal to minus 37. So we can find the value of c as this. We're going to just plug it in back into our equation, which is y is equal to 5x cubed minus 37. All right, so this is just the method. The reason I'm going through this method is we're going to use this in differential equations later on. But it is not good to know that if you are given boundary conditions, these are known as boundary conditions. All you have to do is you're going to substitute your x and y values in your integration that you have found, and then you're going to solve for your c. Okay, so all we did was try to solve for c and got the value of minus 37. Okay, that's what we did. All right. Any questions about integrations in general? Anything not clear about integration before I move on? Because now you guys should be very well prepared when it comes to integration. Any kind of question, at least to this level, you guys should be able to solve. Then from this point moving forward, everything is going to have to do with integration. I'm not going to explain the actual integration. I'm going to explain the concept. And then when I apply the integration, I'll do it directly. So if you have any questions about integrations, let me know from now before I move on. Right? Then let us move forward. All right, let us move forward. So now we were just doing a revision basically for integration. What can we use? Oh, first, this was known as indefinite integration. All right, so what we did was indefinite. What about definite integration? I covered it very slightly last time. All right. But definite integration basically means that you have a value here, let's say 1, and the value here, let's say 5. All right. And then you have your integration. Let's keep something simple like 5x cubed. All right. dx. All right. This is what is meant by a definite a definite integration. How do you solve for a definite integration? The integrating part is exactly the same as the definite integration. All right. So let me use different numbers so it matches the workbook, because someone wanted me to use questions from the workbook. So this was 5x squared. All right. How are we going to do this definite integration? So the first thing you're going to do is the actual integration like we usually do for anything. All right. So from 1 to 4, 5x squared is equal to, dx, sorry, is equal to, again, we're going to just do the normal way we usually do integration, which is 5, the integration from 1 to 4 of x squared dx. I'm just taking the constant out, which is equal to 5, all right? And our integration, which is x cubed over 3, right? Plus 1 divided by n plus 1. All right, and then we're going to have usually a plus c. But in this case, in definite integrations, we do not have plus c because we are given our boundaries, which is 1 and 4. All right, so we have the 1 and we have the 4. Okay? Meaning we have 1 to 4. This is how usually you would write it. It's starting from 1 going up to 4. Okay? How are we going to do this? So we have our constant 5, which is outside. Now you're going to put 2 brackets. So first you're going to put one large bracket for the 5 that is multiplying everything. Okay? Then you're going to put a bracket like this and a bracket like this. Okay? The reason for the big bracket is no confusion. It's just so you know that there's a 5 multiplied with everything. All right? But if we look at the x cubed over 3 now, we're going to write it one time here, cubed over 3, and another time here, cubed over 3. And between these two, there's going to be a minus. The value that is going to go for x in the first one is going to be your top value, which is 4. And the value that is going to be going over here in the second one is going to be your bottom value, which is 1. And then now you notice you can solve this equation with just a calculator. You can plug it into the calculator. Just make sure your brackets are correct or anything. And you will find an actual number for your answer. So this is going to be 5 times 4 cubed over 3. So 4 cubed is 64. 4 cubed is 64 over 3 minus 1 cubed over 3, which is just 1 over 3. So this is going to be equal to 5 times 63 over 3, which is equal to 105. And this is how you would solve for a definite integral. You will always get an actual number. All right. Let's look at another example. Let's look at another example. Let's say we have, let me see here. All right. Let us do from 0 to 4 of 2. Actually, no, I don't want to use this one. This one's very easy. Let's do this one. Integration from -1 to 2 of 3 minus x squared dx. Okay. Again, remember integration. You can do the integration separately here. So this is the same as the integration from -1 to 2 of 3 dx minus the integration from 1 or from -1 to 2 of x squared dx. Okay. All I did was separate these. Whatever is here, I separated so I can do the integration of the first part and then the integration of the second part. Remember, the integration of a constant is not 0. This is not differentiation. This is integration. And remember, this is not multiplication. You cannot just take this outside, all right? This is not multiplication. This is subtraction. So you have to do the integration of both. So in this case, if you remember, the integration of a constant is going to be equal to 3 times x, simply. All right, so all you're going to do is add an x to this. Why is this the case? Because if you remember, this is the same as 3x power 0, because x power 0 is equal to 1. So this is the same as 3 times 1, or x power 0. If we do the general rule here, this is going to be 3x 0 plus 1 over 1, which is equal to 3x power 1, which is x, over 1, which is just 3x. Okay, so this is why the integration of 3 is 3x, or of any constant, it's going to be x. All right? From -1 to 2. Minus x squared becomes x cubed over 3 from -1 to 2. Okay? Now, how do we simplify this? How do we do this? You're going to do the same application we did early on over here for each integration by itself so you can avoid any confusion. So this will be equal to, again, we're going to put 2 brackets over here. All right? This is the first one, and this is the second one. This is for the first part, okay? So this over here is for our first part, which is going to be 3 times 2, all right? Minus 3 times x, which in this case is going to be the value of -1, okay? So this is the first part. Now the second part, we're going to have a minus, and I'm going to put large brackets first because we have a minus outside. So this is minus times everything. That is going to be from this part over here. So this part is coming from this one, okay? So we're going to have our 2 brackets, right? Again, just go step by step. There's no need for any confusion. Just go step by step. X cubed over 3. So it's x cubed over 3. I usually just always write it down with brackets, and there's going to be a minus in between. And then I plug in the value again. So the first value is 2. The second value is -1. These values, again, this is your 2, which is the top of the integration, and this is the bottom of the integration. Usually when you're reading this, you're saying the integration from -1 up to 2. All right, this is what it means. And then you just plug this into your calculator and solve. So this is going to be equal to 6 minus 3 times -1. All right, so this is 3 times -1 becomes -3. This is what you need to be most careful with, the signs. All right, because when you have negative inside, that does not mean it's just going to be minus and then you forget. So make sure you know your signs. And then you're going to have minus 2 cubed over 3 is 8 over 3. Minus -1 cubed is -1 over 3. All right? So again, make sure you are not making any mistakes with your negative signs. Let us simplify the negative terms. So this will become 6 plus 3 minus 8 over 3. Minus and minus becomes plus 1 over 3. All right? So this is going to be equal to 9 minus 8 over 3 plus 1 over 3 is 9 over 3. So it's 9 minus 3, which is equal to 6. Again, you don't need to write all of this and do it. My recommendation, make sure you write these brackets correctly from the very beginning. And then just plug this whole thing into your calculator to avoid any mistakes with the signs, all right? And again, do it in the exact same way I am doing it. Have your brackets all ready from the beginning and plug it into the calculator with the brackets and the parentheses the same exact way, and you will get your final value directly, all right? Any questions about this? Clear so far? Let's do one more example before we move on to areas, all right? There's one important thing you guys need to know. So let us look at this. So the integration from pi over 4 to pi over 2, all right? Of 3 sine 2x minus 2 cosine 3x dx, okay? So obviously, the integration of this is very easy. You guys already know how to do it. We're going to separate and do them each by themselves. But one thing before we start. Here, when you are going to do the calculation, make sure your calculator is in radians. All right? This is very important. When we are dealing with pi, this means that we need our calculator to be in radians. All right? So when you are doing the values, oops, not radius, radians. All right, so when you're doing your values, your calculations, make sure you go to mode, or shift mode, I should say, which is setup, and then hitting 4 to change your calculator to degrees, to radians. All right. So this is out of the way now. Let us actually solve this. So this is going to be, if we separate, so pi over 4 over here and pi over 2 over here, of 3 sine 2x. All right. I'm going to take it a step further from now, and I'm going to remove the constant and put it outside. So we're going to have our 3 outside over here, minus 2. I'll take the constant outside, and then the integration of pi over 4 to pi over 2 of cosine 3x dx. All right, make sure you're writing your dx as well. Okay, so this is now a very simple integration. How do we do this? Again, first thing you're going to do is you're going to write 3 large bracket, and then you're going to have your brackets inside, minus your second bracket over here, and then close the large bracket. Same thing again, minus 2 large bracket, small brackets inside, like this. Okay, always follow this methodology and you'll never get confused. And we know that it is from pi over 4 to pi over 2 for both. All right, so now let us do the actual integration. All right, I skipped the step of the integration. Let me just actually add that over here so that there's no confusion. All right, I don't want to integrate directly. So this is going to be 3 times sine of 2x becomes minus cosine of 2x divided by 2. All right, from pi over 4 to pi over 2. Minus 2 cosine 3x becomes positive sine of 3x divided by 3. Again, from pi over 4 to pi over 2. All right, just doing the integration. Now, when we want to plug in our values, we're going to take it step by step. All right, so this is going to be minus cosine 2 times x, whatever our x value is, over 2. Same thing here, minus cosine 2 times the value of x over 2. All right, what is the first one? The first one is pi over 2. And the second one is pi over 4. Okay? And now we're going to do the same for the next part. The next part is sine of 3 times x, which I'm just going to leave open over here. Make this a bit bigger. We have space. Over 3. And then the same thing, sine 3 times x over 3. All right? It's just the integration that we did. We're plugging it in, but we're keeping the x value open so we can plug in our ranges, which is pi over 2 and pi over 4. Okay? Plug this all into your calculator, and again, I have to state this again. Make sure calculator in radians. All right? Make sure you are always doing your calculator in radians. Most of the time, not most of the time, all of the time when you are doing integration for sine and cosine for trigonometry, your calculator has to be in radians. All right? So make sure that the calculator is in radians, then plug this entire equation in there. You're going to get that. Let's see. You're going to get 2.638 as your last value, as the number. All right? Is this clear? Is definite integrals clear how to solve? All right, just a quick recap. Always you're going to do the separation first. So if we look at, let's look at the same example. So first, you're always going to just do the integration. Don't worry about the limits. You're going to do the integration like you usually do for any normal thing. All right. بتسوون integration هني, take out constants, all of that, as usually you would solve a normal integral. Once you solve it, you are done with it. All you're going to have is limits. That's the only thing difference. All right. You're going to be having limits. And once you have your limits, once you have your integration with your limits, you are going to apply this rule, which is you are going to have your constant outside with a big bracket, and then where your limits are. And inside, you're going to have two brackets where you are going to be writing the integration that you did. All right. But you will substitute for the value of x the upper and lower limits. You have pi over 2 and pi over 4. Again, same thing here. You're going to keep the constant outside and the big outside of the big bracket, and inside you'll have two smaller brackets. You're going to be doing sine 3 of x twice, but you're going to keep the x open, and you will put pi over 2, the upper limit first, and the lower limit for a second. Put this all into your calculator. If you have sine and cosine, make sure your calculator is in radians. Again, I recommend that your calculator is in radians the entire time in the exam because you're not going to use degrees for anything. So make sure you put your calculator into radians before you go into the exam, and then you just get your final value. All right. Abdullah, in the technique that they did, all right, what they did is they didn't separate this for integration. And let me show you how, all right? This is the same exact way of solving, all right? But this way, you will, when you're doing all these steps, you're going to have much less error when solving. يعني الأخطاء اللي بتكون عندكم إياها أقل بوايد. Why? لأن هني you are making sure that you are doing step by step everything. You know where your sines are, where your cosine is, where your the sign of the constants are, and you will not make any mistakes. But let's say we want to solve this directly, all right? Without separating the integration and all of that. We can do that. If you're good with integrations, you can do that. So what are you going to do? You're going to say that this is equal to 3 sine of 2x divided by 2, all right? Minus, 3 cosine. This is going to be minus 3 cosine actually. So minus 3 cosine 2x. Then the integration of sine is minus, so it's just going to put minus, and we know we're dividing by the 2. Minus 2 sine 3x over 3. All right? And this entire thing, you could say, is your bracket from pi over 4 to pi over 2. You can do that. That is correct. Then, all right? Now, if you want to put these into brackets, it is like you see, it's going to be a huge mess. So what you have to do is you're going to have to put a large bracket. All right? It's going to be one bracket here minus one huge bracket over here. All right? Again, from pi over 4 to pi over 2. Okay? So this is going to be your minus 3 cosine of 2. Anything x, we're just going to keep open. 2 minus 2 sine 3 open over 3. All right? The same exact thing, we're going to copy paste in the other bracket. The same exact thing. Okay? So we have our upper limit here. So we're going to put our pi over 2 value here, pi over 2 and pi over 2, and our lower limit over here, pi over 4 and pi over 4. This is also another method of solving if you want to do it directly, if you're comfortable with your integration, if you're comfortable with solving this directly and plugging in all these random numbers in the calculator, you're okay with that, you can do it. But as you can see, you're going to have a lot of different values all in the same place, which makes it a bit messy. Again, this is correct. If you put this also in the calculator, you'll get the exact same answer. All right. So this is a different way if you wanted to do it all in one shot. If you are not comfortable with your integrations, I recommend you separate your integrations and do this for each one by themselves, as long as you understand what you're doing. All right. Tamam. Perfect. So again, this is just a different way. It is exactly actually the same way, but the only difference is we are integrating everything in one shot, in one go. And you guys can do that as well. Okay. It is very important to know how to do your definite integrals, because now the actual topic that we need to start is when you are trying to find the area under a graph using integration. Okay, so what does that mean? Before I go into solving questions, let us just take a quick example of what that means. So if we have any graph over here, let's say we have this graph, okay, and this is y is equal to x squared, okay, and we have points. Let's say that this is 1, 2, 3, 4, etc., etc., okay, and this is 0. Now let's say I want to find the area under this graph from here to here. Okay, let's say this is the area that I want to find. Let's make this blue. Okay, so we want to find the area that is shaded over here. This area, all of it under the graph. We want to find out how much the value of this area is. All right, yani this area we are trying to find. The way to do this is using integration. So you're going to do the integration of y, or in other words, the integration of x squared dx. Okay? This is what you are going to be doing. All right? You need to integrate the function that you have here to find out what the area underneath it is. But how this is going to give us a formula. We don't want a formula. We have a specific limit. Yani as you can see here, we have identified that this is starting from here and ending at this point over here, where our value is going from 0 to 3. So we know that the integration is from 0 to 3. Okay? From 0 to 3. Okay? This is how you would, this is why you need to know your definite integrals. And then it is very simple, the concept. So you have your limit. Where is it starting on the x? Where is it ending on the x? You have your function given, all right, y equal x squared, for example. All you have to do is just to find the area. Instead of writing y here, I'm just going to write area so you guys don't get confused. So area is going to be equal to the integration of this. It is always going to be the integration of your x squared, or of your yani function in this case is x squared. And you're going to have to define the limits. You need to know from where to where. لأن هني احنا حطينا line عند 3. We put a line next to 3. If we put a line next to 4, obviously the area is going to change. The value now is from 0 to 4, not from 0 to 3. Okay? So there will always be limits. So simply, we can find the area. It's equal to integration of x squared is x cubed over 3 from 0 to 3, which is, if we are now going to apply the equation, 2 brackets minus minus 3 cubed over 3 minus 0 cubed over 3. All right? So in other words, again, this 3 is here and this 0 is here. All right? You're going to notice that this is equal to 3 cubed is 9. Sorry, 3 cubed is 27. All right? Over 3 minus 0 over anything is 0. 0 cubed is 0. 0 divided by 3 is 0. So your area is simply equal to 27 over 3, which is simply 9. All right? 9 units, basically. And then we don't have any actual measurement or any unit here given for this. You just have 9 units. All right? Yani whatever the unit here is, it doesn't matter. All right? If they were talking about money, for example, if they were talking about this is $1, $2, $3, then you can say that this is going to equate to $27 or something like that. But the idea is you just have to integrate whatever your function is. All right? It's not minus 9, it's plus, right? Now, this is for a simple graph like this. What if we had a graph that is, let's look at the examples we are given. Let's look at this one. Okay. What if we were given this graph? Right? And I tell you that this function over here y is equal to the sine of x. This is a sinusoidal wave, the sine of x. Okay? So I want you to find the shaded area. How are you going to do this? So the first step here, so here this was simple. Everything was above the x-axis. All right, so this is our y and x-axis. This is y, this is x. All right, so everything's above the x-axis, so it was simple. In this case over here, we have something above and something below. How do you find out the area of this? What you need to do is anything that is above, you're going to put a positive for it. And anything that is below, it is going to be a negative value for the integration. All right. So we know that until this point in the middle over here, let me use a different color. Until this point in the middle over here, all right. You're going to have a whatchamacallit, you're going to have a different sign for your integration. Okay. However, in this simple case, since this is only one graph, we can simply just take from the beginning over here from 0 up to 2 pi. All right. This was given as 2 pi at the end as well. Okay. But I need you guys to understand that whatever is above is positive and whatever below is negative. All right. So how, and we're going to look at an example of that in a bit, but how are we going to do this? So we're going to do the integration of sine of x. What is the limit from 0 all the way to 2 pi? Remember, calculator in radians. Integration of sine x is negative cosine x from 0 to 2 pi. Okay. But this, if we put this, we simplify this, we're going to have our 2 boxes minus 2 boxes from 0 to 2 pi. So it's going to be minus cosine of 2 pi, first upper value, minus cosine of 0. All right. Cosine of 2 pi or cosine of pi is 1. So minus cosine of 2 pi, which is 1. I think it's 1. Let me just make sure I'm right. 2 pi. Yes, it is 1. Minus cosine of 0, which is 1. So minus cosine of 0, which is also 1. All right. So if you notice here, we're going to get minus 1. Minus and minus becomes plus 1. And the area here is actually 0. Why is this 0? Like I said earlier, it's because we have a positive value here and the negative area here. So when you are adding these two together, you are canceling out the area if they are equal. And because this is a sine wave, they are actually equal. All right. No need to know too much about theory, but the idea here is you can get a 0 area if the top part is canceling the bottom part. Okay. This is why our area is 0. So this is actually correct. Okay. Let me just make sure of my working. Cosine of 0 is 1 minus cosine 2 pi minus cosine 0. Yeah, it's 0. I don't know why they have it in the solution as 4. I have no idea where they got that from. But the actual integration is going to show us, as you've seen, it is 0. All right. Minus cosine 2 plus cosine 1. It's not minus cosine 2. It is 2 times pi. Keep in mind. And it's not 1. It is 0. We are putting the limits from 0 to 2 pi. All right. So in the calculator, you wrote from cosine 2 and cosine 1. This is not cosine 2 and cosine 1. This is cosine of 2 pi and cosine of 0. Okay. But otherwise correct. Tamam? Now, let's look at another example. Let's look at, let's see, these are all pretty simple. Okay. Let us look at this one. So far what we are doing is we're finding the integration of one line. Like we're just looking at the area for one line. We don't have many lines, all right? And we're going to look at that in a bit. I'm going to solve this last one, and then we're going to go look at different lines. So here they say that y is equal to 7 minus x squared, all right? A quadratic. So this is our function. And they want us to find the area when x is equal to -1 and, or between, I should say, x equal -1 and x equal 2, all right? So in other words, this is -1 and this is 2, okay? Now, how do we do this? Again, very simply, all you do is integration of whatever your equation is, in this case 7 minus x squared dx. Integration from -1, sorry, from the negative number to up to 2. All right. It's always going to be from the smallest to the biggest in the case of areas. All right. So this is going to be equal to the integration from -1. We can separate it, but I'm actually going to solve it direct here. So this is equal to 7x minus x cubed over 3 from -1 to 2. All right, if we just integrate this directly, the 7 becomes 7x, and the minus x squared becomes minus x cubed over 3. And now we just have to plug it into our boxes. And that's it. So we have 7 into x minus x cubed over 3. Again, 7 into x minus x cubed over 3. Okay, our first value here is the 2. So this is going to be 2 and 2. And our next value is -1. So this is going to be -1 and -1. All right. So this is going to be 14 minus 2 cubed is 8 over 3. Minus -7 minus into -1 cubed is -1 over 3. All right. Again, all you guys actually have to do is just plug this into the calculator to avoid issues with your minus. So it's going to be 14 minus 8 over 3 minus, we're going to distribute here. So minus and minus becomes plus 1 over 3. Actually, minus and minus becomes plus and then becomes minus over 3. So this is going to be 14 plus 7 minus 9 over 3, which is 3. So it's going to be 14 plus 7 minus 3, which is going to be 14 plus 7 minus 3, 18? Yes, 18. All right. This is what you get for part 4. Again, you don't need to do actually all the arithmetics. My recommendation, plug this into the calculator and see what you get. Any questions so far about this? How did you get 2 pi? Early on, the question itself said this. So the question said find area between x equals 0 and x equal 2 pi. All right, this is in the question itself. Okay. No, look, we have the y is 7. Okay, y is equal to 7 minus x. The integration of 7 is equal to 7x. Keep that in mind. That's why this went from 7, here, the integration of 7 became 7x. Okay, remember, when you are integrating a constant, it is going to have an x next to it. Let's take a short break until you guys practice a bit on definite integrals and all of that and understanding the area. We'll be back at 2:05, 2:10, I mean, sorry. So back at 2:10. If you have any questions, feel free to ask. I'll be here. I just want you guys to take a bit of time to understand what we've done so far. And then I'm going to look over at when you have a curve with multiple different, and you have multiple different functions. All right. So take a 5-minute break. If you have any questions, feel free to ask during this break. All right. Before moving on to double curves or multiple functions, let us look at this example. So we are given this curve over here. We're given this curve, okay? As you notice, they did not give you the values of the range. You know that it starts from here. It starts from here and it ends at here. But we do not have our x values. Remember that if you remember from math 1, you can find these are your intercepts. These are your x-intercepts. This is x-intercept, which basically means when y is equal to 0. All right? So you're going to be solving your function when y is equal to 0. So this is a quadratic function, x squared minus 5x equal 0. All right? It's a simple one, so you can simply say take x as a common factor, x minus 5, or you can use mod 5, 3, whichever you prefer, is equal to 0. So we know that one of the solutions is x equals 0. That is our first point. If you notice here, this is x equal 0. All right? Then we have the second solution is x minus 5 is equal to 0, because any part of these equal to has to be 0, so that the equation is 0. So x is going to be equal to 5. So our second range here is going to be 5. All right. So when they give you something that has x-intercepts like this, you should be able to find your x-intercept for basic equations at least. Just a reminder from Math 1, all right? You can go refer to Math 1 videos about this. We went super detailed into it, especially for quadratic equations. But again, it is a very simple way to solve. You can find your x's. And then here, all you're going to have to do is integration of x squared minus 5x from 0 to 5, all right? Let us actually solve this. So if we're going to solve this, it is going to be, this is all dx. So it is going to be x cubed over 3 minus 5x squared over 2 between 0 and 5. Okay? Then you just have to plug in your values. So you do your brackets, your first bracket minus your second bracket. And you're going to have here cubed over 3, 5 cubed over 3, minus 5 into 5 squared over 2. Again, don't get confused. This is just the 5 over here. We're plugging in. All right. And we're going to be doing the same thing again. So it's going to be cubed over 3 minus 5 into cubed or into squared over 2. Again, this is going to be 0 and 0. Don't get confused. This is just the lower limit. All right. If you notice here directly, you can just put this in the calculator, but you notice here directly, this whole thing becomes 0 on the right side. So this whole thing is just 0. So our answer is going to be 5 cubed, which is 125 divided by 3, minus 5 times 5 squared, which is also 125 over 2. And this is going to be equal to 3 minus 125 over 2. You're going to notice you get a negative answer, which is minus 125 over 6. Okay? The reason you get a negative value, okay, don't get confused. The reason you get a negative value is I explained this already. It's because the area is underneath the x. All right? It is going below the x. That is why it is a negative area. All right, so the actual area is 125 over x. Okay, the minus value is just showing the location of the area, whether it's under or above the curve. Okay, so you could, if you see an answer that says 125 over 6, it is still correct if they're talking just about area. And if you see both positive and negative, make sure you put the negative answer for the multiple choice. All right, so this is basically it for this question. Let's see if there's one more. I want to do one more like this, so you guys just know how to find. All right, let's do this one. So yeah, okay, this one's a good one. So they gave you this graph over here, right? They gave you this graph. And if you notice, this isn't a quadratic anymore. This is a cubic, okay? We have y is equal to x cubed minus 4x squared minus 7x plus 10. So you cannot just put modify 3 to solve this. But in this case, they gave you this point is equal to 1, okay? This point is equal to 1. So the way to solve this is, again, it's the same exact concept, which is x-intercept, which is when y is equal to 0. All right, so we know that this whole equation, x cubed minus 4x squared minus 7x plus 10 is equal to 0. Okay? The way I would solve it, me personally, I would take x common in the first few values. So it's going to be x common, x squared minus 4x minus 7 plus 10 is equal to 0. All right? And then I would factorize this value over here. All right? So it's going to be x times. Remember, if you want to do factorization, you can either do mod 5.3 or you can do direct factorization. That's up to you. Just 1 second, just 1 second. Okay. I just realized you don't even need to do all of this. You do have mod 5.4, which does actually solve for this equation. Okay. So mod 5.4, if you notice on your calculator, I don't want you guys to get confused with math. I want you guys to take advantage of the calculator wherever you can. So if I remove all of this, so if you hit mod 5.4, mod 5.4, okay? Mod 5.4, you're going to notice that it is ax cubed plus bx squared plus cx plus d equal 0. All right, so it is the same form that we have over here. Simply just now identify your values. So a is equal to 1, b is equal to minus 4, c is equal to minus 7, and d is equal to 10. Okay, so I can be a bit more clear. This is going to be our b, which is minus 4. This is our c, which is minus 7. And our d, which is minus 7. And our d, which is 10. All right, so minus 7, this is your c. 1, which is x cubed. This is as if it is 1x cubed, right? This is the same as saying 1x cubed. Okay. Your minus 4 is from your b over here, your b value, and the plus 10 is your d value. Once you put this into your calculator, you're going to hit mod 5.4. You're going to put a is 1, minus 4 is b, minus 7 is c, and then 10 is your d value, and then you're going to hit equal. It is going to give you all the values that you need. So it's going to say x1 is equal to 5, x2 is equal to 1, which they already have given us, and then x3 is going to be equal to minus 2. All right, very simple. So our 1 is already given over here in the middle, and then you go in order. So minus 2 is obviously going to be the first value, the smallest value, which is minus 2, and then your excuse me, and then your x1, which is 5, is going to be over here. Okay, you guys have to know how to do this, obviously, the smallest to the largest. Now, all you're going to have to do is integrate from minus 2 all the way to 5. So we're going to do the integration of from minus 2 to 5 of the function that was given, which is this one, x cubed minus 4x squared minus 7x plus 10 dx. And then you're going to go and do all the steps that you've seen before. You can either do it integrated all as one step to make it easier for you guys, or if you're too confused with integration, you can do each one and separate them one by one. So if I would integrate this, I would integrate in one step. So it's going to be x cubed over 3 minus 4x squared over 2 minus 7x squared, x power 4 over 4 minus 4x cubed over 3, all right, minus 7x squared over 2 plus 10x starting from minus 2 going to 5. Then you're going to have your brackets on the left and right. I'm going to make as much space as I can. Minus your bracket on the right. So the first one is going to be brackets over 4 minus 4 over 3, or 4 brackets cubed over 3 minus 7 brackets squared over 2 plus 10 times brackets. All right, same exact thing you're going to be putting on the right side over here. All right, it's the exact same thing. Okay, but the only difference now is you're going to put your 5 here. So 5, 5, 5, and 5. And then you're going to put your minus 2 here, minus 2, minus 2, minus 2, minus 2. All right, put it in the calculator, you get your final answer, and that's that. And that's going to be the area. All right, is this clear so far? There is one more that I just noticed, which is power 4, and you cannot just do that directly in the calculator, but there is a trick to it as well. So if you have this type of function, it's very simple, very easy trick. All you have to do is you write that y. Actually, you don't even have to do the simplification. They already gave you all the limits. So you just are going to integrate x4 minus 5x squared plus 4, starting from minus 2 all the way up to 2. So you're going to start from the very first point where it's the areas are you're getting them all the way to the end point. All right. This is how it is for the area under one curve. But what if you had two curves? What if you had multiple curves, yani? For example, let's say the question says, a simple example, very simple example. Let's say the question says this. Find the area between the curve y is equal to x squared, the lines x equal 2 and x equal 4, and the x-axis. So if you're given a question like this, you have to be able to plot a basic curve. So we're going to put our x and y axes. All right, this is our y, this is our x. So the first thing we want to plot is y equal x squared. Remember, y equal x squared. The way to plot it is you find your intercepts, you find your x and y intercepts and all of that. Here we know that when x equals 0, y is equal to 0. All right, it is a simple curve, so it starts from the 0 point over here. And because it is positive, so it's going to be a smiley face. If you remember, again, revise your math 1. Smiley face, and we know the intercept is only one intercept over here at x equals 0. So basically, it's going to look something like this. Like this. Okay? This is how it's going to look like. The lines x equal 2 is up here. This is 2. X equal 2 is the straight line going through the value 2. All right. X equal 4, same thing. It is a straight line going through 4. All right. Let's say that this is 4. Okay. And this is 2. And the x-axis, which is just the black line from the x-axis there. So what are we finding? The area that is between all of these three. So this area over here. That is between the 2 and the 4, the curve, and the x-axis. This is the area that we need to find. If you notice here, this is a very simple example. All you need to do is, our function is y equal x squared. We're going to integrate from 2 all the way to 4. That's where the shaded area is, from 2 all the way to 4, of x squared dx, and then you just solve for it. All right? Very simple, very straightforward. Keep in mind when they say x-axis is basically when y is equal to 0. All right? This is the same meaning. The x-axis is when y is equal to 0, because this is just a straight line, a horizontal line, when y is equal to 0. All right? Just extra information. And that's it. And then you're just going to do the integration of this, and you're going to find a value. Let us look at something different a bit. All right, let us look at this example. I don't think they're going to actually ask you to plot this, but just in case. So they're saying find the area between the curve y is equal to x. So if I draw my x and y, this is my y, this is my x. The curve between y equal to e to the power of x, the lines y equal 1 and x equal 4. Let us draw y equal x. Y equal x is going to look something like this, all right? It is an exponential growth, so it's always going to be increasing, and it starts from the point number 1, all right? This is how a basic e to the power of x looks like, okay? If you want to plot it and make sure you're right, you can always plug in values. So when x equals 0, you're going to notice it's e to the power of 0. Any value to the power of 0 is 1. So just so you have the y-intercept is when x equals 0. So y is equal to e to the power of 0, which is simply 1. All right, this is why it starts at 1. I'm not going to go too much into detail with this. What I need to look at is the other lines. Those are what you really need to know. Y is equal to 1 and x is equal to 4. So y is equal to 1. Now we're looking at the y-axis. Y-axis meaning we are looking at where it is intercepting with 1. This is our line. Y is equal to 1. All right, it is a horizontal line that is going through the value 1. All right. This is, again, y is equal to e power x. And now we need to look at the x-axis when x is equal to 4. Let's say that this is 4. All right. It's going to be a straight in the middle here. That is enclosed by all these values. All right. Okay. This is the area that we need. How do we do this? Again, if you notice, it starts technically, the curve is starting from here. Okay, if I am making it a bit larger, so it's just a bit clearer. All right. So this is what the curve actually would look like. Okay. So it is increasing a bit from here. So the blue part is all the way till here at a smaller scale. All right. So if I'm making this much larger, it's going to be clear, but it starts all the way from point 1. So our first value of x, this value of x is x equals 0, all the way to x equal 4. So now we can do the integration of the curve, which is e to the power of x. All right. Now, this is where the important things happen. Okay. So let me just remove this a bit and make it a bit larger so it's a bit clearer. So remember that this is our horizontal y. And let's say our e to the power x looks like this, just so that there's more space and you guys can see it a bit more clearly. All right. It looks like this. Okay. So this is our y equal e power x. But if we are looking at the area, if we are just writing this equation over here, this is going to be this entire total area over here, right? It's going to be all the way to the x-axis, but we don't want that. We don't want this purple area, all right? we want the area only up to y is equal to 1. All right? We only want to y where y is equal to 1. So we are going to subtract the integration of when y is equal to 1 dx. All right? Again, if we did this equation by itself, e power x dx, we are integrating this entire area all the way to the x-axis. But we don't want this part, right? This part, this area, is where y is equal to 1, right? So this is where y is equal to 1. The equation of the line is y equal 1, okay? So we want to remove this part. We don't want this part to be a part of our total area. That is why we subtracted, excuse me, we subtracted this part away from the total area. So we had minus 1 dx. In other words, you can always remember it as the function above minus the function below. Okay, this is how you find the area between two parts. So it is above minus below. This is always going to be the case. And what is the range? It is starting from 0 to 4, 0 to 4 for both of them, because this is your x range going from here to here. So it's always going to be the above minus the below. The above is y equal e power x. The below is y is equal to 1. Okay? And that's it. And this is how you will actually do your integration. So it's going to be the integration from 0 to 4 of e of x. E of x, the integration of it is simply just e of x from 0 to 4 minus 1 is going to become x from 0 to 4. And then you're going to open up each of these by themselves and you will solve. Is this clear? Is this clear? This is a very important concept to know. Okay? This is a very important concept to know. No questions? All right. Let us do some more examples so that you guys get a better hang of the whole idea. As usual with math, you just have to practice until you understand it very well. All right. So let's see if there's any similar questions to this. Unfortunately, there isn't. This was the only one that has boundaries like that. Give me a second. Let me try to find a question like this. All right. I'll make up a question later on, but for now, let us just practice what is given in the worksheet. So let's look at, for example, this equation or this question. So the question says, find the area bounded by these curves, all right? So we have three curves. We have y is equal to this value, this formula. Then we have our x is equal to 0, and our x is equal to 4, and the x-axis. So we don't even need to draw it. You know, guys should know by now that these x values are your range, all right? So the x value is the range. So basically, in other words, it is going to be from 0 to 4, all right? So we don't need to look at these anymore. The x-axis, basically, x-axis, remember, I said that this is the same as y equal 0, all right? So if we're applying the same method here, above minus below, it's above minus 0, which is y equals 0. So again, the x-axis is already dealt with. We don't need to look at it anymore. So all we have left is the integration from 0 to 4 of our function, which is minus x squared plus 8x dx, okay? And then you just integrate and you'll be able to solve, all right? This, obviously, you guys need to practice as much as you can. Me, I'm just trying to focus on the concept of how you would find your actual integration, all right? Let's look at another example. Again, very simple, same idea, same concept. Here it says y is equal to e minus x. So this is our y function. This is our x equals 0 and x equals 3, meaning that this is from 0 to 3, and that's it. This is what we benefit from x. And then the x-axis, this basically means y equal 0. All right? So we have from y equals 0 to y equal minus x as our functions, and the x values is going to be our range. All right? So y means function, and x means our range. All right? This is how it's always going to be. So now this is going to be the integration from 0 to 3 of of e to the power of minus x. Technically, minus integration of 0. Technically, because our x-axis, like I said, is as if we have a y equals 0 line. All right? But we don't have to put it at all because integration of 0 is just 0. So this is going to be your integration, and then you have to integrate. Let's actually integrate this. I want you guys to tell me what the integration of this is. Just the integration, not the range, any of that. Just the integration of e minus x. What is the integration? What is the answer? So what is the answer over here? I'll give you a clue. There's going to be an e for sure. But what is the actual final answer? I want to see how good you guys are with your integration. Because if you noticed so far, the hard concepts are not hard. They're very simple. The only thing that you may make a mistake in is the actual integration. So tell me, what do you think the integration of e minus x is? I said the integration, not the actual value. I want the actual integration of e minus x. Okay, ignore this question. This is the question now. What is the integration of e minus x dx? Without the value, what is the integration of e power minus x? Yes, this is what I wanted to see. It is going to be minus, let me do it step by step. So it's e power minus x divided by minus 1. All right, so in other words, it is equal to minus e minus x. Okay, a lot of people usually forget this minus 1. They see, oh, e to the power x means it's the same thing. All right, but make sure you're looking at your signs, and the range is from 0 to 3. From 0 to 3. All right, and then you're just going to do your minus e to the power of minus 3 minus e to the power of minus 0. All right, remember, e to the power minus 0 is not 0. Okay, so make sure, if you want, you can plug this directly into the calculator because e is a constant. Or actually, when you have e, you most probably will have to solve, because in a multiple choice exam, you're going to be given the answer in terms of e. So this is going to be minus e to the power of minus 3. Minus and minus becomes plus e to the power of 0. E to the power of 0 is 1. So it's going to be minus 1 over e power 3 plus 1. Or in other words, 1 minus 1 over e to the power of 3. All I did was, because we have a minus here, so we took it to the denominator. All right. You need to know how to do all of this, because in the exam, especially when it comes to exponents and the numerator denominator, because in the exam, you're going to have a multiple choice. Any answer could be given. Okay. This is pretty much it. Let's say just one more example, just in case, for where you have y. Actually, let's do it without a curve, just in case. Then, so let's look at the same exact example that we did earlier, which is this one. It says find the area between the curve e to x, the lines y equal 1 and x equal 4. All right. So let's say we don't want to plot it. All right. And let's say this isn't y equal 1. Let's say this is y equals 3x. I don't think you're going to get 3x, but just in case. All right. Just in case. So this is the only question given. It says find the area between the curve y equal x, the line y equal 3x, and x equal 4. This isn't a line, actually. This is a function. All right. And x equal 4. Okay. So we know that this is going to be from x and x equal 4 and x equal 0. So we're going to know that the range is from 0 to 4. We know that much. We know that the first y, it's going to be the upper, okay? And I say that this is above. So it's going to be e to the power of x minus the other one. Let's say that this is below. The integration of 3x dx from 0 to 4. All right? I don't think they're going to complicate it this much, but the idea I want you guys to understand is whatever is above, if you are given the graph, especially like here, whatever is above the function, in this case it's y equal to power x, you're going to subtract whatever is below, in this case y is equal to 1, and that's pretty much it. Okay? We are done with integration with graphs and all of that. We're not done with integration, but we are done with the graphs. Any questions about this so far? Before I move on to separation. Separation is very easy. Trust me, it is very easy. The differential equations, super easy to solve as long as you know how to integrate. If you do not know how to integrate, you're going to have a hard time. But if you're good with your integrations, differentiation, at least at this level, the differential equation solving is very, very easy. All right, let us start with that then. So let's go through a little bit of theory so you guys get a better understanding of what we mean by a differential equation. A differential equation basically means, all right, that you have a differential in your equation. That's it. So, for example, dy plus over dx plus y equal 0. All right. This is what is meant by a differential equation. Okay. Sometimes they're going to be linear. Sometimes they're going to be non-linear. In our case, we're only dealing with linear, and I'm not going to go too much into theory about that. And then there's something called also a homogeneous equation and a non-homogeneous equation, meaning if this side is 0 or if this side is a number. This is all that it means. If it's 0, it is homogeneous. If it's not 0, it is not homogeneous. But again, I'm not going to go so much into theory. All you guys need to know that this is what a differential equation looks like. So you're going to have a differentiation and you're going to have the variable itself over here, or something like this, like d5 dy by dx minus x squared equal 3. This is also a linear differential equation, all right? And this is what we are going to be dealing with now. But how would you solve such an equation? How can you find the value, or how can you find what is meant aslan by solving this? The idea of solving is to eventually come out with an equation where you have y is equal to some constant times x plus b, for example, or either in this way, or x cubed or x squared. So basically coming out to a function. This is how you solve. Solve as in finding y is equal to x. So in other words, no differentiation. So we are removing the differential part of the equation. All right, this is what is meant by solving a differential equation. You're going to see this a lot, especially if you're in engineering. You're going to be seeing this almost everywhere, especially in Math 2. You're going to do it in much more complicated scenarios as well. But for now, it is in the most simple and basic form. And if you're good with this, you're going to be good with all the different forms you will see in the future. And you need to be very well rehearsed in your integration. إذا ما تعرفون الانتجريشن وايد بيكون صعب عليكم the integration part, not the solving of this, the integrating of this. And you will see how now. Let us take an example from the worksheet and start from there. So let's say we were given that dy by dt is equal to 2t into 25 minus y. All right? We are given an equation here, right? So the first step is separate the variables. What does this mean? You're going to want your dt to be with your t value, and you want your dy to be with your y value. All right? This is the whole idea of separation. So we're solving it with the method of separation of variables. And we can do that very simply if you know how to do your basic integration, or sorry, basic arithmetics. And then if we want to rearrange this equation, we're just going to take the dt to the other side. So this is going to be dy is equal to 2t times 25 minus y times dt. All right, all I did was I moved this dt and put it here. That's all I did. Okay, this will always be your first step, trying to separate these two. In this case, it was very easy to separate them, but we will see cases where you need to do a few more steps before so. But it's all arithmetics, yani it's all basic algebra. If you remember, if solving a transposition, it's the same simple idea. So now we have our dy over here, our y over here, and we have our t over here and our dt over here. So far, what did we get? We got our dt and our t in the same place. So we have finished our first separation. All right. So I'm just going to keep this here, so you guys know that's what we are doing right now. So we are separating the variables. So now what is left? We need to get this part to the other side. All right. This is what we need to do. We want to have our 25 minus y with our dy. Okay. So in other words, we are going to divide both sides by 25 minus y. So it is going to be dy over 25 minus y is equal to 2t times dt. If you notice here, now we have our dy with our y value. They're both in the same location. And we have the t value with our dt value. All right. Okay. So this is our very first step. All right. This is the separation that I was talking about. We wanted to separate these so that they are both on the same sides. The y is with the y and the t is with the t. This is our first step. Now the second step is integrate both sides. So now we have to do an integration of both sides. So we're going to have the integration of 1 over 25 minus y times dy. All right, this is the same thing. I just put the dy outside, so it is a bit easier. It's equal to the integration of 2t dt. All right. We did not do this integration before. I don't know if you guys are going to get this integration. All right. For now, I'm going to just stop here, but you're going to be doing the integration for both. All right. I don't want to solve this in a complicated way. I know there's a simpler way, but I'll be honest, I'm not sure of it right now. So I don't want to solve this integration. I will check and get back to you guys in the next session. But let me just continue the steps. All right. So you will integrate both sides. Once you integrate both sides, you're going to get a value for y over here. And you're going to get something here with y. And you're going to get over here on the right side, you will be getting 2t. It becomes 2t squared over t over 2. dt becomes plus c. All right, so we're just going to have plus c over here. All right, this will actually be the ln of y. All right, this is going to be the ln of 25 minus y divided by a constant. Okay, but again, I don't want to go into details of how I got this, but it's simply the ln of the bottom. All right, and then there's going to be a constant as well over here. All right. So now what do we do? Now we have to solve for y. How do we solve for y? First things first, we need to take, let me remove this. If you want to solve for y here, you need to do the e to the power of both sides, if you remember, to solve for a Lin equation. So this is going to be e to the power of Lin 25 minus y is equal to e to the power of 2 and 2 cancels over here. E to the power of 2t squared. All right, not 2, it's just t squared. All right. Let me see, everything's good. Yep. Minus y is over there. Okay, yeah. All right. So it's going to be e to the power of 2t squared again, plus c will always stay outside. I'll talk about it in a bit. All right. All I did was I raised both sides to the power of e. Remember that Lin cancels with e. This is your logarithms, if you remember. And what will remain is 25 minus y on the left side. And here it will stay as e t squared plus c. Okay? Then you're going to have minus y is equal to, we take the 25 to the other side, so it's going to be e t squared plus 25 plus c. All right, the c will keep it always on the side by itself. It does not get affected by any of the calculations. So we're going to have that y is equal to e minus 25 minus e t squared plus c. Okay. Again, this was just integrating both sides. You guys need to make sure you're good with your integration so you'll be able to find out your final answer. And this is how it will look like. All right. But how do we find our value for C? To find your value for C here, you're gonna have to have a given in the question, as I will show you in a bit, with the boundary conditions. But in this case, we don't have any boundary conditions, so this will be the final integration. All right. Let me do a simpler example. So you guys, I don't want you guys to get confused by the integration part. I want you guys to understand what I did when it came to the separation. All right. So let me start that with a simpler example. Let us look at, all right, it's as simple as can get. Let us look at this simple example. dy by dx is equal to x times y. All right. Again, the first step is separation. Separation meaning you want to separate your x and have it with your dx and your y and have it with your dy. All right. In this case, separation is easy. All I have to do is move the dx to the other side. So it's going to be x times y times dx. All right. Just multiply both sides by dx to get it over here. And now I need to move my y to the other side so it can be with dy. So it's going to be dy over y is equal to x dx. And now if you notice, our x's are together, x and dx is together, and y and dy are together. So now we can say that we can move on to the second step, which is integrate both sides. Okay? So it is going to be dy by y is, in other words, the integration of 1 over y dy equal 1, or integration, sorry, of x dx. Okay? So we are integrating both sides. What is the integration of 1 over y? It is going to be ln of absolute y is equal to the integration of x. What is the integration of x? X squared over 2. And then we're going to have our plus c at the end. Again, how do we get rid of ln? Because we want, remember, the idea is to achieve an equation where y is equal to something. So we want y to be by itself. How can we get rid of ln? We raise both sides to the power of e. So e to the power of ln y and e to the power of x squared over 2. Right? Plus c. The e with the ln will cancel, and what will be remaining is y is equal to e to the power of x squared over 2 plus C. And this is how you are solving a differential equation. Again, I repeat, we will have to separate the variables. Any x's, we will keep it with dx. Any y's, we'll keep with dy. Make sure that dy and dx are separated from the very beginning. And then you just solve. Okay? Now, let's look at a bit more complicated equation. Just a little bit. So we have y minus x dy by dx is equal to 6, right? If you notice here now, the separation, you cannot really do it directly. But what do you have to do? You have to keep dy and dx by itself on one side. So what can we do? We can either move the y to the other side, or we can move x dy to the other side and bring the 6 here. That's up to you how you want to do it. So let us do the first step, which is separation. So y is equal to 6 plus x dy by dx, right? Or actually, let's do it the other way so you guys don't get confused. Let's keep the dy on the left side. So minus x dy by dx is equal to 6 minus y. Okay? Now, if you notice, we have our dx here in the denominator, all right? We want it to be in the numerator. So what can we do? We can multiply both sides now by x, so by dx, so it's going to be minus x dy is equal to 6 minus y times dx, all right? Again, all I did was move this up here. That's all I did. Minus x dy is not correct. We do not have the correct separation, all right? We need our y to be with dy, and we need our x to be with dx. Okay? So how do we do that? We are going to take the x to this side, and we're going to take the 6 minus y to the other side. So we're going to get dy over 6 minus y is equal to dx over minus x. Again, don't get confused. All I did was I took this down here, and I took this down to the other side. Okay? Is this clear? Now we have our dx's and dy's together. So dx and x is together, and our y and y are together. The last step would be integration of both sides. So in other words, you are going to integrate dy by 6 minus y, or in simpler terms, this is 1 over 6 minus y dy is equal to integration of 1 over minus x dx. Okay? And that's pretty much it when it comes to separation of variables. You're just going to have to separate them, and you just have two steps. The first step is to separate, and the second step is to differentiate. All right? I wanted to do one with boundary conditions, but unfortunately, the time is limited. But next session, I will start it with a revision of this, a revision of the differential equations, and also boundary conditions as well. All right. Any questions about this before I move on? I mean, it is the end, but yes, this session is recorded. No worries. If this is very confusing, no worries. I will show you how to integrate all of this again in the next session. But I need you guys to make sure you understand this part, because the integration, it is very basic. The integration is just applying the rule for integration. However, here, this is the idea. The idea is to know how to do your separation when it comes to this. That's it. All right. I'll stop the recording here. I hope it was clear. Just make sure you practice your integration